So to the back of our notes, they have already done the measurements for us, and they talk about tangent, sine, and cosine, and they make those relationships to opposite and hypotenuse and adjacent like we did on the front. If you look at our triangle, we have an angle A, we have an angle C, and we have an angle B. You're going to use those to tell you, for example, in number 3, we're supposed to find the tangent of angle A. So, we're going to stick with all of our angle A's first as we go down through exercise 3, 4, and 5, and then we'll talk about reference angle C. So bear with me here a minute. For 3, 4, and 5, angle A is here. So the hypotenuse, the side opposite, and the side adjacent are all determined because we're using angle A.
Why? But there's no other degree.
Right, we don't care what the degree is. We're just talking about the length of the sides right now. So don't worry about the actual angle. Like in the front, we had a 20 and a 50 there. So tangent is opposite divided by adjacent. So our side opposite divided by adjacent. That's all you've got to do for today.
So that's it.
That's it. You don't even have to make it a decimal. Okay? You certainly can, but you don't have to. For the sine, it is the opposite divided by hypotenuse. So 3 divided by 5. And again, that's all you need to do for today. Cosine is adjacent divided by hypotenuse. You don't have to put them as a decimal even. You certainly can. It's not wrong. And those decimals are pretty manageable. Now, things change when we switch to using C as our hypotenuse. Or excuse me, as our angle. So we're going to use angle C now. This is still the hypotenuse up here, but now this is opposite and this is adjacent.
So you're basically just finding
They are reciprocal functions. Very nice. Well said. So tangent of C is opposite over adjacent. Sine of C is opposite over hypotenuse. Cosine of C is adjacent over hypotenuse. Let's come down and look at the second example on the back. Now, there's a nice little way to remember sine, cosine, and tangent. And we pronounce this so, ka, toa. So the so is sine is opposite over hypotenuse. Ka is cosine is adjacent over hypotenuse. Toa is tangent is opposite over adjacent. There are other mnemonics that work. One that's popular among kids is some old hippie caught another hippie tripping on acid. And I think kids remember because it involves a hippie and acid, and that's just kind of something that you wouldn't say in school. I don't care which one you use. I will always say so katoa. You are welcome to think whatever you'd like in your mind to help you. So let's go ahead. Now remember, pay attention here. We have two different angles that we're referencing. Angle A we'll do first. So this is the hypotenuse. This is the side opposite, and this is the side adjacent. So sine is opposite over hypotenuse, and we're just going to write the fraction. Cosine is adjacent over hypotenuse, and we're just writing the fraction. Tangent is opposite over adjacent. And again, we're just writing that ratio, that fraction. Things change here just a little bit when we switch and talk about angle B. The hypotenuse doesn't change, but now opposite and adjacent flip-flop, because B is our reference angle. So cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And sine is opposite over hypotenuse. Maybe you've already seen it, but I'm going to draw your attention to some connections, if you will. When we switched from angle A to angle B, our opposites and adjacents switched. So you may have noticed that we have the same ratio, but it's for a different function. The same thing happened between cosine and sine. Different functions, same ratio. And then for tangent, again, same function, different ratio. Those connections will continue to happen if you stay in the same triangle. For your homework, you won't need a calculator or a ruler for tonight. You simply need to write the ratios like we did on the back of our homework.